Okay, so let's talk about fisheye perspective. So, yeah, first let's again kind of establish very general concepts. So, like, what is perspective? Perspective is, it's about like drawing illusion of 3D space, right? So in 3D space, it's we have three axes, Y, Z, and X. These three axes basically they represent this three dimensions. So these three dimensions being like a foundation for a form, because like three-dimensional form, and every three-dimensional form it's a box. Okay, so it's a so-called box logic, right? So it means kind of like every form have a front, back, left, right, top, and bottom. Is like it's just like a way how human perceive space and just kind of like reality around us, right? So, let's say here we have like back, front, and etc. Left, right, top, and bottom. So this box logic, it's about space and objects. So every object is practically a box, and every space it's like being inside the box. So when we're talking about objects, it's kind of we're looking from outside, like being outside of form. And when we inside certain form, we consider it as a space, like a building, like a house, kind of, right? Like you inside house, um, so you are inside the box. You are outside house, you look at house and it looks for you as a box because it have front and sides and all this stuff. And even when you in the open space, there you will have like idea of sides with you anyway. Anyway, you like always will have idea about where is front, where is back, where is left, right, top and bottom. We this is just like how we build, because with this idea of space, we like we can orient in a space, kind of, right? So we have like directions where we can move, we can track a location of stuff. So, and then you see an interesting thing about this box logic. So let's say cube. So we have main directions like back, front, left, right, and the top, bottom. If we look top view, right? So it will be like this. So it's left, it's right, and this is like front, and this is back. So we have this like coordinates. So what it shows you that, like, let's say like front, it will be this like 0 angle, right according to front, it will be like 90-degree angle. And between left and right, we have 180 angle. Okay, so same with vertical. So if I look from side view, so let's say side view. So here is back, there is front, here is top, and here is bottom, right? Same kind of with this side view. So when you like to front, we take as a 0 angle. To bottom, between front and bottom, we have like relationships like 90-degree angle. And between like bottom and top, there is like 180. Same like between back and front, 180, etc. So this is coordinates, right? Like firm structure of 3D forms. So, but what if, let's say again here, top view. What if we want to be like more precise, like being somewhere in between front and right direction, for example? What it want to be like 45-degree, like let's say between front and right. So have like this direction, like 45 angle, right? Or let's say if here is 90-degree, 0, or like this kind of direction. How can we track it? How can we measure it? So, and this happen with, so this where we start to have idea of sphere, because you see between the center and this sides, it's the same distance, right? So like from you to front, from you to right, it's kind of this beam with the same distance. So no matter where its direction will be, it will be like same distance. So from a top, it will make circle, right? So let's move the circle, kind of ellipse, this belt. So now when we have circle, okay, we can have it like kind of like a protractor, I think it's called. So here you can like put all angles. So we have here 0, here will be 90, here will be 180, here will be 180 plus 90, 270, and then we back to 0, it will be 360, right? So then you can subdivide. It's like 45, like 135, and 22 and half, yeah. And here is like 67 and half, and etc. So when we start to be like more precise than just like front and right, but let's say like you want to like point exact direction and say like 22 and half degree kind of angle, right? So for this we need to think in a concept of ellipses and circles, kind of this. So when we talk about horizontal, like directions, right, in this x dimension, horizontal, then it's like make this like horizontal ellipse. When we talk about vertical, see this y here. So for vertical, we will have vertical ellipse. For and for this depth, we'll have so we'll have these three ellipses. So then have sphere. So this, you see, kind of think about what is 3D, kind of, right? So let's kind of like make it clear. It's very complex, so you see it's like advanced perspective, and it's just like purpose of this video is just clarify every uncertain aspects for you. But yeah, it's better you have already experience drawing in perspective. So again, look, so what is 3D, right? 3D, it's y, z, x, then it means it's a box logic. So from having like three axes, we have this sides, we have form, right? So axis, form, and then it's like more sophisticated kind of thing. It's a sphere, just like being more nuanced, right? So so this make, like, let's say axis, form, and sphere give you like more like precise, yeah, let's say precise kind of, let's say, so like you see, it's all about just 3D itself, just kind of like a abstract idea of 3D, like mathematic kind of, right? So we take some object and we look like what is made of, right? So it can be like a simple box, or this can be like box with some diagonal elements or some like spherical, elliptical stuff. So all operations you do with 3D form is kind of based on this. It's like axis, sides, like box logic, and angles. These angles, right? So your ability using ellipses to figure out, arrange proper angles. So, but then we need to like involve one more aspect. This aspect is like observer, right? So this is just about 3D and 3D forms. But there is somebody watching them, somebody perceiving them, somebody experiencing this 3D world, 3D forms. So can be like viewer, observer, camera, you, whatever, right? So, and interesting, like it's very interesting kind of like recursion kind of here, you know, like a fractal fractal recursion. It's like because observer himself, like this camera kind of visual system itself have 3D properties. This 3D properties because it's like way you look at things, way you perceive things visually also follow 3D properties. So because look, here's you, right? You looking somewhere, you have your direction, your like line of sight, your vision direction kind of, right? And now look, immediately you will have opposite direction. So if like you look in there, we can call it front, then will be like opposite to it, this like a back, right? Then will be a direction 90-degree from your uh, kind of looking direction. 90-degree from your looking direction will be right direction, right? So 90-degree to the left direction will be your left. So we have front, back, right, left. Same, so you looking here straight, right? And then 90-degree from your direction of look will be your top, and 90-degree going down will be your bottom, right? So what is crucial here is about a relationship to your direction of your sight, like where you look. It's like creating this like a beam laser, because there will be this narrow field of view where you can see things clearly, sharply, you can observe details, right? So then you see how from this narrow field of view it will go, let's say, vertically and horizontally. So more it goes horizontally, right? Like it start to be blur. You losing focus. So focus about here, very small area. But there we have like background kind of field of view became blur. And then about like let's say horizontally about 180, you totally lost vision, right? So about it's like close to 180, you don't see any detail, you just see movement, kind of some move there. So it's like you can notice movement and you can turn your head and you will see, you will look what is happening, kind of, right? So same kind of with the vertical, you see, so it goes and somewhere here, even before 180, it will become like you will lost your field of view. Can just like experiment with a hand, like you look straight, move your hand and notice when you lost any visual information. It's like kind of like for about 45 angle. So you see, it's this idea of like angles, like in an elliptical um, form, kind of, right? So like I draw, oh, where is it? Let me show you. Ref. Так. Okay, yeah, so like this, right? So you see, um, so on this ellipse, you have this point, center of your vision. It's your direction. So where it's clear, then it's like when you see how it move along this ellipse, it will like disappear, kind of, right? So, and here is interesting thing, because if we speak about people, right? So you have this limited vision. It's like vertically about, um, say, vertically somewhere about like 45, and horizontally, let's simplify, it's like 180 and 45, let's say, right? So, um, it's like your field of vision is there. It's this field of vision is like this area on a sphere. So, and what is interesting, like in your mind, actually you have full sphere. So physically, like literally, you can see only this part of a sphere, but mentally, kind of, you have idea of a space around you in a full sphere. It's like you don't need to look directly to what is around you, but you know what is there. So like, because I've been walking here around, so I have data about environment. So now I know, I look in here and I know behind I have wall, behind I have kitchen, kind of, I know I have ceiling here. I don't need to look at it. I remember it, right? So, and this is very interesting moment, because visual perception have these layers, like one, like first layer kind of is like your sharp perception, then like second layer is this like blur perception. When you can't see detail, you see movements, right? So sharp is details, background vision is movement. And the third layer, it's like uh, it's already kind of like your imagination. So your brain built idea about where you are right now and what is there. It's like a vision in your mind, like when you see visuals when you sleep. When you like dreaming, you think you see stuff, when in reality you don't see anything, because you don't use your eyes. Your eyes is closed, right? So same here, like if you just will try, uh, kind of like, meditate on this idea, kind of just think about it. Yeah, this, you will notice this, how you perceive space, how you perceive like environment, is like three levels of visual perception. And third kind of type of visual perception, it's kind of idea concept, which is not hallucination, it's actual reality, because it is just like a buffer. Because like right now I look back and I refresh my memory, so I confirm, yeah, what I know behind me, I confirm it's exactly what I know. So because I have experience, I know nothing changed there, so it's still there. So you see what kind of I'm talking you about is that general idea of 3D. General idea is that the 3D, it's a box and sphere at the same time. Same, it's apply to your idea of visual perception. It's also have 3D properties. It's yeah, so, and I call it visual sphere of visual perception. Так. So what important here, like when you look at some object, like I don't know, here sharpener, right? So let me just say this, it's a top, right? So now when I rotate in it, we see how whole structure, it's remain like it's not changed, right? Like it's not skewed. It's just whole structure is rotated. So this top and front relationship remain stiff. So when I rotate it, it's not changed. It's like 90-degree angle between them remain same. Same properties, like rigid properties, work with the visual system. So this kind of very important to understand. When we draw in perspective, like you go and you look some, you know, like let's say we have horizon line, we have vanishing points, and you see like, oh, here vanishing point, some stuff going to this vanishing point, like vanishing point 1. And then we have vanishing point 2, and here other stuff going to this vanishing point 2. Okay, but it's absolutely random vanishing points. Like different case when we talk specifically about vanishing point Z and vanishing point X, referring it to um, to sphere kind of, right? Or because on a 3D system, this is vanishing points Z and X, they stand to be kind of represent this 90-degree relationship, right? So when I go draw line to Z and I draw line to X, it means here will be a 90-degree angle. Okay, so it can be like different points, but then there is a point which is referred to visual system or box logic. Так, so let's see some comment. Okay. Yeah, thank you for a comment. We'll look for it. So here, yeah, I hope it's clear, right? So again, talking about 3D in general. So you see 3D is 3 coordinates, box, sphere. It's all 3D, 3D form, 3D space. Then we say like, hey, but there is somebody looking at 3D form or from within 3D space somewhere, right? So, and a way someone or something look, visually perceive, also follows these 3D principles. Once you have direction of your sight, this direction will be built in 3D system. So you will have like direction to front, you will have now direction to opposite way, you will have left, right, top and bottom direction, right? Okay, but now one more thing, because this visual perception and space, they kind of like connect, they intersect, let's say, right? So, and so what we see it's the result of a real relationship of your visual system and the space. So it's the two 3D system like interconnecting. So visual sphere, like sphere of visual perception, and space. So yeah, so when we talk about visual perception of space, we're talking about your visual sphere within box, but yeah, can like more fundamentally it's a cube, right? So we have this visual sphere in a cube. Okay, so these two different 3D systems, that's what is very important. Is like it's two different visual 3D systems. They have same properties because it's fundamental properties of any 3D form, but there is a totally different stuff. Your visual sphere and space or environment. So, but also we can talk about, let's say, like your visual perception, your visual sphere, and if like it's not a space when you inside the space, but it's a like object. So in this object, when it's object, it will be inside your visual sphere. Let's say like this, right? But when it's a space, it means your visual sphere inside this space. You see kind of like hierarchy kind of I'm trying to explain here. So let's say again, hierarchy, maybe like in a 2D form. Space is like a cube space. Then your hello team visual sphere, visual inside this cube of space. And then we have object, which is also kind of box. And this object is within your visual sphere. So it's kind of like how they located object. Because you see, it's like visual sphere. It's something. It's just like I don't know. Let's say like it can be like minimal size is like around your head, and maximal size it's how far you visually can see anything. You know, it's like if you're in the ocean, in the open, like or in the desert, right? So at certain point you can see any more farther, and this we call horizon line, right? So this is your limit of visual sphere. It's your maximum like size of your visual sphere. So imagine like how huge it is, right? So and so it can be this big, and it's also can be like a small kind of as your head or as your room. It's just like mm, it's like again, it's like parameters in the equation. You choose this um, between these numbers. Like you have minimal and you have maximum, and you choose which one you want to interpret, what you want to consider. So, but anyway, inter kind of relationship happen in this hierarchy. Space, it means you inside 3D form. Object, it means this 3D form inside your visual system, inside your visual sphere. Так. So then let's see what kind of interaction I'm talking about, what kind of like relationship of a visual sphere and space is happening. Так, let's draw. Three space. Yeah, you have no idea how difficult to explain stuff nobody explained before. It's kind of weird feeling. Так. So here's this space, right? And here your visual sphere. So in one case, your visual sphere in relationship with the space, that your axis, this like z axis, y axis, and x axis parallel to space. You see, so x parallel to the sides of a space, y parallel to this sides of a space, and z parallel to z of a space. So this XYZ system and of a visual sphere uh, align with XYZ of a space. Kind of like, again, easiest example, it's a house, a room, right? So now like I am in a room, here's my room. So here is my head, and I'm looking here. So my direction of my side is the parallel to wall on the left from me, and the wall to the right from me, perpendicular to wall to back from me, perpendicular to the wall in the front of me. So my visual sphere, my visual system align with the axis of a space. Then what if like I move direction of my side so it became not parallel? So let's say I don't know, let's say like this. So now we have this z-axis, this will be y axis, and here x-axis. So me moving direction of my side, moving whole my structure of my visual sphere perception. So and now when if it happens with only one axis, like right now here I show is vertical rotation. So if like from a side view, so side view, you can say, okay, here is Z of a space of a room in my house, and here it's Z of a direction of my site. Okay, so now look what we have. We have angle here. It's not parallel anymore. We have kind of angle, and like in this case I can say it's like about 30 degree. So here you see at that point idea of camera rotation start to make sense, because what do we mean when we talk about camera angle, camera rotation, or like your vision angle? It's always about relationship between your camera and space. Okay, so and we're talking about exact angle when we compare like direction of a space with which we can align. So it's like if, like in the first example, like camera have zero angle because it's just aligned with this room, and like it's a top, oh sorry, it's a front here, right? So it's like front side of a room or front side of a space, and your camera front direction go in there. So your front align with the front of a space. So we're talking about zero angle. When your front, your direction not align, we're talking about difference. This difference have parameters which we show, measure in the angle, measure with the, I forget how to say in English, degrees, measure in degrees, right? So this difference we measure with the very specific numbers. We can like calculate it very specifically. So, and this movement can happen in a one axis, so like vertical direction, um, for example, right, or horizontal rotation, or this kind of z-axis rotation, called so-called Dutch tilt. And it also can rotate simultaneously. So you can have like horizontal and vertical rotation together. So now I'm look down and while I'm looking to the right. So like I have right now like rotation 45 angle down and right together at same time. So let's say like here, no, it's not 45 down, but it's like 22 and half down and 45 to the right. So my z rotated to the right and my x rotated to the right. So you see what we're dealing with? We're dealing with this relationship of a visual system, visual sphere, and space. We can be very specific with what kind of condition we have. So it's like parallel or in a certain angle to each other they have, only by using this XYZ system. And then, so I hope it's clear. You see, again, it's like it's so complicated to like explain it gradually. I'm like blowing my mind to explain it, but it should be clear. It's not for beginners for sure. Again, recap, right? Recap. First, you understand what is 3D. It's axis, box, and angles. Angles, it's a sphere. Then we have 3D systems. 3D of visual perception and 3D of environment. It can be space or object. Then we have relationship between space and object. Space is always outside of your visual system. Object is always inside your visual system. Then we have what kind of relationship, because it's a dynamic relationship between space and visual system and also between object, but with objects it's easier. Yeah, we'll talk about this later, but first, like really like most confusing thing ever, and you never see it anywhere, nobody explain it to you, only me. It's a relationship between visual system and the space. So because you see, it's just like fundamentally explain you what is camera rotation or direction of sight. It's always is this subjective relationship between space and certain visual system. It can be camera or it can be you. And only then, next step. What is next step? Write me in the comments. You're crying already? What is next step? Next step is how to show all this in the image, right? Like how we show it. Because yeah, this is always like a interesting information, interesting like equations, theory, metaphors. But how we will show it? Uh, and we show it generally, right? We show it in a 2D surface. So we want to show this like interconnection of two 3D systems on a 2D surface. How we do it? Oh, it's called projection, right? So it's like kind of like a shadow theater, right? We have this 3D space, 3D forms, and we project them onto the surface. And so this what happened, like specifically we're talking about fisheye, because like if we talk about simpler perspective, it's much simpler type of projection. Yeah, well, kind of I explained this in the previous videos. Maybe we'll explain it again later, but let's focus on fisheye. So now all this stuff, right? Let's talk about how we draw it onto the surface, how we project this thing. So first, you need to understand projection of visual system, like visual sphere, right? visual perception sphere. So projection of visual perception sphere, it's basically it's 6-point perspective. So 6-point perspective. So in the core you have like 5-point perspective. So you see like which pen to use. Got this. So it's like a z vanishing point. Here's x, x. Here's y, y. So here. So this will be like 45. 45. Can you see it? So here 45. 45. So if this one is 0 angle, here's 90 degree, here is between 45 angle. So z-axis goes this way. X goes this way. So within this circle and this circle itself, it's 5-point perspective. So it became like 6-point perspective when the stuff go outside of circle. So we have x-axis go outside and y-axis go outside. Okay. So that's it. Kind of basically, this is projection of visual sphere on a paper. So what happening here, it's you see this one, this area, it's your this narrow vision here. So it's this type of perspective which we kind of draw when we draw 1-point perspective. It have like less distortion. So we have like parallel y and x axis, and we have this like z vanishing point. So it's about this area here. Then we start to take more from this visual sphere. Like we start to take bigger area from visual sphere, and it start to be more distorted. So this vertical axis start to like curved, right? So and when it go to 90 degree, distortion became like so surreal. So it's kind of like we'll almost never draw it there. Even like Kim Jong-gi or whatever artist you look, they will draw always like little inside. Better don't go to this X on the right, because like practically you will never measure it. It's too crazy distortion. It's for 3D programs, not for freehand artists. And then when we go outside of this 5-point perspective circle, it means we go in like already like farther than our left and right side. It's already like back of our field of view, and it became like so crazy distorted. So it's like unrecognizable. So And it's basically kind of like very good representation or projection of this visual sphere, because anyway we never practically see what is behind, right? So no reason to find way to project it to make it clean. But of course there can be like some other perspective grids, like let's say this kind of perspective grid you can draw for like virtual reality projection. If you've seen these images, let's say I already forget how to draw it. So it's kind of like this z vanishing point, and let's go kind of this to back, something like that. Whip. So y-axis will be like this, and so we have z-axis goes like that. Whoops. And then we have like x, so it's like left and right, let's say, right? And go like this. So here is like a visual sphere projected, kind of like similar to map of Earth planet, right? So we have it like a map projection on how to say, kind of scroll, right? Like a scroll. So in here is horizon line, and this horizon line. So this is first step, kind of like first also visual perception sphere. And then we're talking about projection of this visual sphere relationship with the space. Okay, so, and first type, it's the most kind of simple and clear and like common type. So it's like, let's say, can draw it here. So let's say we have this 6-point perspective grid, right? So how we will see this relationship when your visual system parallel to space, which in this case it's a cube, so it's like absolutely symmetrical cube. It will look like this. So this how you see um, like whole cube from inside, like 360-degree. Let me clarify. Pencil to take one. Let's take this blue. So here you see it's a front side. Here it's a left, right side, top, bottom. And this stuff here, it's a back side. So you see it's like back side being like explode like this. So front here and back side, like back side of a cube. This one, it's here. So yeah, you can see it. But imagine like how crazy distorted it is. So same like here, yeah, we can draw like how it looks here in this type of projection. So it will look some kind of this. So what we have here, we have this front side of a cube and this back side of a cube. So, you know, like, yeah, usually it's like cut in half here. So this kind of perspective grid for this. So, and so you see in 360 6-point perspective, so we see whole visual sphere and we see uh, space. It will look like this here, so it's like rear side explode. On this type of perspective grid, this 360 view, we will have exploded, oh, kind of exploded, I don't know how to tell it. It's like top and bottom, which kind of like visually look unnatural, kind of. This is what I mean. So, but then, oh, then we start talk about crazy stuff. It's like when we have this like rotated tag. So let's say if we have yeah, let's break it here. Break it here for 5 seconds.
Madness. This is Jane Bond art.
So when we have like visual sphere, your view rotated, so let's say it's space and your direction kind of looking 45 angle to right. So it will be like this perspective grid. So, and you see I've been drawing these perspective grids many times in my videos. So here kind of main point of this tutorial is to clarify what you were looking at, right? What how it works, because people keep asking me about like you're turning your eyes or you're turning your head. Okay. Um, turning your eyes, basically it means that you, like what you say by turning eyes, it means you're using like less field of view. So you like drawing this area, or you drawing this area, or you drawing this area. So you choose small area from your visual sphere. So because um, yeah, because when we talk about fish eye, we're talking about we're like taking more information from your visual sphere perception. And in a human case, it's actually impossible view, right? Nobody see the fish eye. We don't actually see it. Like here we see movement around here. What in the back I don't see at all. So, and we start to see fish eye when we start to use wide lens camera, right? Or like right now we have 360-degree camera, so it start to show us like full visual sphere. So when drawing perspective, right, making this projection on the paper onto the surface, it's always a certain simplification. It's like metaphor, like I'm trying to show you here. None of this it's real. Nobody see it this way, right? So we already making it like kind of like art. It's just art which very much based on mathematics, right? So because of science, kind of, we can see this stuff. If we don't have science, we will never see it. So it's already kind of made up thing. It's kind of just important to be aware of this stuff, right? So, and every projection we draw, it's all made up stuff. It's a human like artificial things, like a metaphor of visual. So and like thinking about it's like so hard to explain. Like when you draw fish eye, you draw fish eye. So draw all stuff which is related to fish eye type of perspective, and don't think too much. When you draw like simple, more like schematic perspective, more like this kind of like less field of view perspective, you draw in them following these conventions of this type of perspective. Okay, so and only what you actually need is to remember why you study perspective, right? Because I tell you, you will break your mind, you will break your head if you will try first to figure out all perspective and then you finally will start to draw. No, you will never, you will never understand. Like, it's because it's made up. Like, you will never understand this completely. You will go to, like, you need to get Nobel Prize, kind of, you know. So better like ground all this on what you want to draw actually, right? So and let's see. So okay, let me show you some in a PureRef here. Okay, so here I make some examples. Так. So what I show you, right? So this is 6-point perspective, 6-point perspective grid. You see, this is kind of like a maximum field of view you can like possibly see. You see how beautiful flower it makes? It's some kind of like a magnetic field. It's so surreal, so cool. It's beautiful. It's like some kind of like a sacred geometry stuff. So this how all this system look if we like stretch it to maximum, like to absolute maximum till this moment of technology, because I don't know what later will happen too. So you see like how this back side it's explode here, and this we see like 5 sides of a sphere. So then when you rotate the camera to 45 degree to right, this how it start to look. So now we have exploded left and back walls, and we have like this kind of exaggerated stretch top and bottom. Так, so, and here let's see how it looks on a less kind of extreme projection. So here you have your favorite fisheye perspective. So here your camera rotated to the right, but you see what is trick about is that while your camera is rotated,
Madness.
your visual sphere is always there in the same. It's always same sync. Okay, so what you see here, you see projection of a space on your visual system. Now this space projected in this manner, and when you want to show this on a 2D surface, you make projection of this projection. And to make this projection of projection, you use special perspective grid, which I show so many times already kind of on the previous tutorials. So for this to show horizontal camera rotation, we move kind of this X vanishing point to here and the vanishing point to here. So now you have this grid. So and here in this grid, you show this space in this relationship. Okay, so and if here you ask question kind of like, okay, so this is like rotation of my head, but what about rotation of my eyes? In this situation, rotation of your eyes is just a wrong question. You don't need this, because if you want to consider rotation of your eyes, it means you need to avoid fisheye concept itself. So now you're like, okay, you just want to draw like 2-point perspective, for example, right? Or you want to draw 3-point perspective like here, right? So you will have this kind of view. So whole this complex kind of theory about visual sphere, about projection of visual sphere and the space and blah blah blah, you don't need for drawing this type of perspective. Okay, so and in otherwise in other around kind of, right, like if you draw fisheye perspective here, you don't have rotation of your eyes because you kind of showing your visual sphere, like if you can see it, like it's like if your cone of vision is not narrow but your cone of vision is like whole freaking sphere. You can see clearly 360 degree. This what is perspective means. So concept of rotating eyes don't work anymore. You don't need to concentrate your attention on something when you see everything. You see what I mean? So that's it. That's it. So yes, we have a rotation of 360 degree camera. We have this rotation, but it's not your eyes. It's about geometry of a visual perception and the geometry of a space. Так. No, okay. So, okay, let's say if you like, you have like two cameras in a room, right? Okay, let's say you have two cameras in a room. So you have room, so one camera is kind of higher than other camera, right? So one camera is this high. Wait a second, my cat is screaming, maybe needs some food. Let me check.
Who are you?
My name is Bond.
Jim Bond.
So one camera is high, another camera is low. So it's kind of like a human and dog, right? So, and they look maybe even in different directions. So this human here like kind of look in the corner, dog is kind of looking to, don't know, looking here to this wall, kind of parallel to space. So, and you want to draw them like they see with the fish eye. I don't know how big field of view of dog, but anyway, it's already became like kind of artificial idea, right? Because human don't see fish eye, but you want for fun kind of draw it, right? So we will have like two views. So this guy, he look to corner, so he will have this so let's then make his horizon line here, his eye level here. So here, because he look 45 degree according to system of a space, so we use this 45 degree horizontal rotation perspective grid. So then we look like, okay, his height, we can, if you want, you can like measure precisely. So let's say here, it's look like we have ratio, like he is like 3 and 1, right? So it means here, his eye level. So here we will have like 1, and here 1, 2, So this kind of will be this space. So here will be ceiling, here will be floor. So, and if we have like door here, okay, can draw door here. Так. I always forget this y-axis. I forget y-axis here's going wild. Yeah. Here comes. Or do here. Так. Okay, again, so it's just like should be smaller. So we have like this ratio. Like above his eye level, it's one part. Below his eye level, 3 part. So here we have corner. Here will be this side with a door. Make mistake. Так. So, and he even like, if he have a dog here, so, and his dog parallel, so his dog parallel, standing parallel to space. Yes, he's kind of loose. It's kind of this, like a box of a dog. Woof, woof. So, and what dog will see? So dog look same. You see, we have like a height of a dog. So we can say it's like 1/3. Here's pretty big dog. So eye level of a dog compared to walls is like 1/3. So in here I can make eye level just in the picture frame, and I make it lower because I know I have more space to show above eye level. And because dog looking with 0 degree, so we'll have this like classical 6-point perspective grid. Так, let's say like this. Так. Then we'll look 2 above, 1 below. So, let's say, okay, so these are ratio. Так. Here will be door. Так. So, and there we have a dude standing. So let's see. Okay, this dude ratio, he's like to like double height of a dog eye level. So if he's standing here, then whoop, whoop, this will be his height. It's like, what's the matter, Wolfie? Так, can draw like some floor. So I don't know, I hope you, this what you ask. So a different view, it means like different relationship of visual system with environment. So when we talk about relationship, yeah, you see like I start to mention, it's like placement of camera observer within space, right? So we can talk about like how close to walls camera, or how how close to ceiling or to ground, right? So basically it's just because front, back, left, right, or ground and ceiling is just sides of a box, right? So when you talk about placement, you talk about distance between. So it's like can be like right in the middle between these sides, or it can be closer to one of sides, and then you can use a ratio to define, like let's say like it's 1 and 1 measurement to ground floor surface and 3 to top, for example. And same you can like, I have video about this. Again, it's like you see, it's like talk about all this stuff can take forever, and nobody will endure watch all this stuff in one video anyway. So, but back to theme of this video, it's explaining what is fisheye perspective, right? So you see, we start to have kind of fisheye when we start to have this like curvature, right? So we start to have this curvature because we start to put in your picture, in your projection, bigger part from visual sphere. So if you want to take all visual sphere in your picture, it will look like this 6-point perspective grid. If you want to take like almost like you see it's like front half of a visual sphere and little more than front half. It's like little more than half of visual sphere. It look like this. It look like 5-point perspective with some extra space. And then we're talking about, you also show like how camera can be rotated. So if camera rotated 90-degree up, so you will see same 1-point curvilinear perspective or 5-point perspective. Like if you look into the front, it's kind of same perspective grid, only instead of front you have now top. Same if you 90-degree looking down, you will have like instead of front you will have bottom. So it's like will be instead of the vanishing point, it will be y vanishing point, aka nadir. And same like with right, I guess. Yeah. So, and then it became like another perspective grid. Another perspective grid is like when it's not just you switch vanishing points, but you really need to draw different structure. Is when you draw angle between 90 degree, 0 and 90. So it's like most use kind of as a standard, it's 45 angle, but then you can draw any other angle using this principle. So here we have like horizontal rotation, like I show you already this perspective grid. So it's like it's already fisheye, but it's still look like curvilinear 2-point perspective, right? If we take more field of view, it start to look more distorted, and here you see it start to look like this, and then this kind of 6-point perspective, 45 horizontal rotation, you will have this perspective grid. This look like this. So again, like I say, it's just for you in case if you want to see like how far it goes. So what is there, where all these lines will go. So you can see like, you see it's like this fisheye perspective grid is basically is like if you zoom in and you take part from this perspective grid. So it's just like if you are so curious, like me and some crazy people, here's answer for you is like where all this structure goes, how it works. And then what will happen if you look vertically 45 degree, it's kind of same grid, but like tilted, right? So basically same grid. But it became very interesting when we have horizontal and vertical rotation at the same time. So you will have this structure. Here again, you see it's like with a moderate. What does mean moderate? It's mean again, it's you take lesser part of visual sphere. It start to be curvilinear because you start to take pretty big part, but it's not this like 6-point perspective type yet, because you take only like you see about 100 degree from visual sphere. When you start to take about 180 degree, you start to see like very crazy stuff like that, right? So here you have like 45 angle horizontal and vertical rotation. This is how it looks. And if we like again take it more, this is how it looks like if we like distant to maximum from all this stuff. Okay. So
Who are you?
back to a very important point. Again, you most likely you don't understand what point of all this stuff. It's kind of like, oh, it's crazy, it's too much, or like you think you understand, but you actually don't understand. I mean, just like 100% it don't make sense or pointless for you if you not able to draw in a fisheye to this moment. Like back to practical points, like what do you actually want to draw? and try to draw it. And unless you able to draw like, you know, just some standard fish eye, or like some fish eye, like after videos like what I show in my tutorials, don't dig too far. You're not ready for this information. You need some practice, like understanding complex information should be followed with a practice. You learn, you train, you see you can do it, now you want to go to next. If you want to, you learn, you try, it's just kind of like, okay, I understand everything, but where's your drawings? Can you show me your drawings, like you're really drawing fisheye perspective? And when you're able to draw something in fisheye, which look like decent and a certain level, then after this kind of situation, you go and look for stuff like this, just to expand your understanding, because it's too much and useless information for you in beginning, and it doesn't help you to draw if you not start to practice, and you will keep kind of like theorizing, like, oh, this gene, like, if maybe he make mistake here, like, yeah, like here I did mistake, like, blah, blah, blah. Just kind of, because I talk, kind of making videos kind of very difficult. So, but instead of playing science and trying to get Nobel Prize in theory of perspective, you do it gradually, like show your results, start to make work, and then go to next step. Come back here to my channel, and yeah, became like virtuoso. Okay, so hope it was helpful. Write me in the comments whatever you think. Just try and do my best. See you next videos.
I say what I mean, and I do what I say.
Madness. This is
Gene Ball.